Number 6, I've got a multi-part here one. So A, what is the formula for sodium hydroxide? I'm hoping that you now recognize that hydroxide is a polyatomic ion. And because it's a polyatomic ion, you need to look at your polyatomic ion sheet. Okay, that might seem like it's very easy to do, but if nothing occurs to you, if nothing makes you realize that that's a polyatomic ion sheet, you're not going to get it out and you're not going to get the easy points. So please recognize that as a polyatomic ion. If you do recognize it as a polyatomic ion, it's really easy to get out your polyatomic ion sheet and see that hydroxide is in fact OH with a negative charge. Sodium is just sodium, but the reason that we need to know what hydroxide is so that we can know how many sodiums we need to balance out whatever negative charge comes on the hydroxide. Polyatomic ion sheet tells us that it's a -1. So because sodium is in main group 1, it forms a +1 charge. So we'll just need 1. So our formula is going to be NaOH. B asks, what is the formula mass for sodium hydroxide? Well, now since we know that there's 1 sodium, 1 oxygen, and 1 hydrogen, we'll simply add up all of those masses and correcting for the appropriate number of significant figures, we will report 40.00 AMU. Then we move on to C. What is the mass in grams of 0.25 moles of sodium hydroxide? Well, again, this is a conversion. We're going to use the molar mass of sodium hydroxide, which we just calculated, and we're going to use that as a conversion factor right here. If you're wondering, but Johnson, B asked for the formula mass. I thought that's why we wrote it in terms of AMU, atomic mass units. Down here, you need molar mass. That's true. But remember, numerically, formula mass and molar mass are the same. The only thing that's different is the scale. And because the scale is different, that means the units are different. So the molar mass of sodium hydroxide is 40.00 grams per mole. So I will start with the 0.25 moles of sodium hydroxide that the problem gives me, and then I will put moles on the bottom of my conversion factor, put grams on the top of my conversion factor, carry out the calculation, which is 0.25 multiplied by 40 divided by 1. We end up with 10 grams of sodium hydroxide. And because this question gives me 0.25, that's 2 significant figures, I'm going to report my answer with 2 significant figures as well.